Alright, so let's take a look at this integral, the integral of x cubed over square root of 16 minus x squared dx. If you notice, down at the bottom in the denominator here, there's a root 16 minus x squared. 16 is a perfect square, so this is in the form of square root of a squared minus x squared. And that means that we want to use the trigonometric substitution, x equals a sine theta in order to render this problem integrable. So let's do that. A in this case is 4 because a squared is 16. So we'll make the substitution x equals 4 sine theta. And so that means that we have x cubed over square root of 16 minus 4 sine theta square dx. And notice that we can turn the x cubed on top to 4 sine theta cubed as well, over 16 minus 4 sine theta square dx. And so let's simplify this a little bit before we go and turn the differential dx into d theta. So this is going to be 4 cubed, that would be 64, sine cubed theta, all over square root of 16 minus 16 sine squared theta dx. And finally, we get that this is 64 sine cubed theta over square root of 16 is 4, so we can pull out 4, 1 minus sine squared theta. And remember that the whole point of using trig substitutions is to render square root of something squared plus or minus x squared into the square of a trig function. Over here, 1 minus sine squared, remember, is cosine squared, because sine squared plus cosine squared is always equal to 1. So we can actually just go and rewrite this. We may as well simplify 64 over 4 to 16. 16 sine cubed over the square root of cosine square, which is just cosine theta dx. Okay, now we have the integrand figured out. We need to turn the dx into d theta, and if you go back up here, remember that x is 4 sine theta. So let's do this on the side here. X equals 4 sine theta. Dx would be 4 cosine theta d theta. So remember that in the trig substitution, you don't have to divide by the derivative of the substitution. In fact, you multiply because you're doing a slightly different thing. This means you'll get 16 sine cubed theta over cosine theta. Dx is now 4 cosine theta d theta. And the cosines go away, so we have, ooh, look at that, a 64 all over again. Integral, or rather, let's pull the 64 out, integral of sine cubed theta d theta. So the question now is, how do you do this integral? 64, well, ignoring the 64, the integral of sine cubed theta d theta. There's several ways of doing it. You may know of the reduction formula that converts this to an integral of something assigned to a smaller power that comes from integration by parts. I'm going to do this using a slightly clever method. One that takes advantage of trigonometry because we have sines, so we don't have to go and do parts or anything that complicated. Notice I broke the sine cube up to sine and sine square. So I'm going to take advantage of the fact that, remember, sine square was 1 minus cosine square, so I'm going to take advantage of that Pythagorean identity again and rewrite sine theta as cosine theta. This may not make sense right now because, well, why am I including, more stuff here, essentially? I have another type of function as opposed to just sine. Well, if you look at this, first of all, the first part, sine theta, that just becomes negative cosine theta when you integrate this. Um, Now, however, the sine cosine square theta we can actually do with the substitution or change of variable, because now we have this sine theta, which is the derivative of cosine theta. So this is sort of a result of a chain rule thing going on. So let's just do that on the side with blue maybe. So let me let u be equal to cosine theta. Then that means that du is minus sine theta d theta, and so d theta is equal to du over minus sine theta. That means that this integral can be rewritten as integral of sine theta u square du over minus sine theta. Conveniently, the signs cancel out as expected. And so this is negative integral u squared du, which is negative u cubed over 3 plus c. And remember that u was cosine, so this is minus cosine cubed theta over 3 plus c. And so let's put that back in the green stuff. So we have 64, that's equal to 64 times minus cosine theta, and I believe there was a minus sign there. Yep. So minus that integral. Since that integral is minus cosine cube over 3, it's now plus cosine cube over 3, and plus c I'll move to the end. Of course, we're not quite done yet because the integral is in terms of theta, and we want the integral in terms of x. So let's go back and let's see, what is x? X is 4 sine theta. So x is equal to 4 sine theta. That means that sine theta is equal to x over 4. And we can figure out what cosine theta is by essentially drawing a triangle. Theta's here. Sine's opposite over hypotenuse, so that's 6 and 4. X and 4. And so by the Pythagorean theorem, this is 16 minus x squared, which looks kind of familiar. So the cosine of theta would be adjacent root 16 over x squared over hypotenuse, which is 4. So we can now substitute that back in, and you get equals 64. I'm going to move the negative term to the end, so it's going to be, let's see, root 16 minus x squared over 4 cubed times 1/3 minus root 16 minus x squared over 4 plus c. And let me just write this out a little bit more neatly. Equals 64 times square root of 16 minus x squared cubed, or the 3/2 roots of 16 minus x squared, or 3/2 power, sorry, over 4 cubed is 64. 64 times 3 is, I believe, 196 minus root 16 minus x squared over 4, or plus c. That is the integral that's the antiderivative of our original function, which, let's remind ourselves what it is x cubed over root 16 minus x squared. So a quick review of what we did. We used the trig sub x equals a sine theta because we have square root of a squared, which is 16 in this case, minus x squared in our integrand. And when we did the integral, when we did the substitution, we got the integral of sine cube. And there's several ways of doing sine cube, but the way that I did it here is that I rewrote sine cube as sine times sine square, and then turn sine squared into 1 minus cosine squared, multiply everything out, and use a change of variables, use the substitution to do the integral of sine cosine square. And then finally, as in all trigonometric substitution problems, you want to write the answer in terms of x or t or whatever variable you had, not theta. So you draw a triangle, you write down what the substitution gave you, and you attempt to solve for the other trig functions like cosine, or if you need to, tangent, secant, cosecant, cotangent. And ultimately, you plug everything back in, and you have the indefinite integral. You have the antiderivative.